Alright, this is Ken Roosevelt. We're continuing our discussion of t-distributions. So last time we did this problem. It was very simple because it's asking for the probability of a t that's greater than negative 120. Negative 1.20. Degrees of freedom were 9. And we got 0.8696, so it was 0.87. I have to retype all this in. And then we were looking for C and negative C such that 95% of the area would be between those two values. And so that was pretty simple because we just did T of alpha, this button here, and on it we put in 2.5%, so 0.025 in the first box, and the degrees of freedom for that were 29. So that was the t-distribution we were employing, and there it is, 2.045. Now our next problem might be a little more involved. We're going to hit more practice here. Notice on this one, it's asking for the area in between negative 1.5 and positive 1.5. So real quickly, let me just click down there, take a little picture. Alright, because it's asking for the area in between, I'm going to first show you a picture and then I'm going to tell you a little shortcut formula for whenever you have a problem like this. There's a very easy way to do it. So even though I'm using a standard normal curve here, you know, the pictures are pretty close. So it doesn't matter. This is still a bell-shaped curve. And we're doing a t-distribution with 14 degrees of freedom. So let me just put that. D of f is 14. That's important. But we want to find the probability of t coming up that's between negative 1.5, which would be right there, and positive 1.5, which would be right there, because the mean is right there. So we want that area in there. Well, the only problem is the button always gives us the area to the right of our cutoff value. But that's not really a problem, because what we can do is we can put P of t greater than 1.5, and that'll be this blue area right here. Now I want you to think for a second. Not only is P of t greater than 1.5 this area here, it's also this area here. And if we add both those areas together and subtract it from 1, won't we have the green area? Yes, we will. So if we go 1 minus 2 times P of t greater than 1.5, that will be our answer. When they ask you for the area in between and they have the same number in both places, it's a cool little trick. In the ALEKS calculator, here we go. So I'm going to go 1 minus, and you see because it's t greater, it has the right hand thing there. So I'm going to do 2 times that, and it's going to be t greater than 1.5. Degrees of freedom is going to be 14. So I just put in a 14 there, and I hit enter, and it's 0.84417. So we'll just call it 0.844. All right. Now they also want you to be able to do this one. This one is actually not hard at all. I don't even need to leave. It says consider t-distribution with 5 degrees of freedom. Find the value of c such that p of t less than or equal to c is 0.10. Actually, I will leave. I'll go back to my OneNote and erase real quick. They want us to find a c so that the probability of getting a t less than c is only 10%. So knowing that, I know that it's got to be somewhere like way over here. And this area to the left is 0.10. Well, the problem is the P of t button has a greater than symbol, so it's always going to give me the area to the right, to the right of C. Oh, whoops. Actually, I don't even know what C is, so I can't even use that button. The button I'll be using is T alpha. But alpha also is always to the right. Okay, is always a right tail. If you know what's in this right tail, you can plug it in here and it'll give you the T if you put in the right degrees of freedom. Well, I do know what's in the right tail. It's 0.990. So that is what I'm going to put in to my ALEKS calculator. And I don't want to put in 0.10 because that's the left tail. I always use the right tail. So going back to ALEKS calculator, this button right here, I'm going to put in 0.9 and my degrees of freedom are going to be 5. And that's it. It's negative 1.4758, so negative 1.476. Negative 1.476. I hit an extra number in there. 476. And that's it. That's how you do those. I don't know that they get any more complicated than that. I think that pretty much covers some of the cases. And if it doesn't, try to employ your logic and think, how can I get the area I need using the buttons I have available? All right, that's it. I hope that's helpful. Bye. Actually, you know what? I'll do one more for you guys just in case. You never know. I have time. All right. So last one here. Consider a t-distribution, 26 degrees of freedom. Compute the greater than one. That one's not hard. And this one we'll do in a second. So the greater than one, there's a button for that. We just put in P of t greater. Doesn't matter. Again, this one has an equals and this one does not, because the equal sign has no area, except if it's a binomial thing and then you actually make a correction for continuity to give it area, but that's not important. We're just going to put in 1.2. You can't do anything else there. The degrees of freedom is 26, so it's pretty close to normal. And we hit enter, and it's 0.8795, so we'll call it 0.88. So 0.88. And now this one, they want C such that it's cutting off 99% of the population. Well, it's cutting off 99% in the center. It leaves 1% split equally, or 0.5% on either tail. So the upper tail, the right tail, will be, the right tail will be 0.005 because it's a 0.5%. And the degrees of freedom are 28. And when I hit enter, I get 2.763. And that's my answer. I put it up there. Let's try that again. 2.763. That's it. That's how it's done. Okay. That's enough of that. Hopefully this is helpful to you and you'll get it. Bye-bye.